With my 2-gallon portable compressor on standby, I was now able to test the system. Doing this with only 2 hands was very fiddly because the hose is very rigid. I'm having to block off the other air port and ensure the assembly isn't flexing to avoid binding. It did run though, which was an enormous relief. However, the setup had to be just right. The piston had to be positioned in a specific location, and I had to blast a quick surge of air to get it going reliably. During most of my tests though, the wheels would rotate by only like an eighth to quarter of a turn and then stop. The temperamental nature of the assembly made me question if I had done something wrong, because the valve piston was always in the same position when the wheels locked up, blocking off the steam admission ports. I began to wonder if the steam admission ports weren't positioned right or the valve dimensions needed to be altered. After rewatching some videos on steam locomotive function, I noticed that the animations also show moments where the valve piston totally occludes the steam admission ports. So, if my design was proper, then why was the system not behaving? Then it hit me. Steam locomotive drive wheels are quartered, meaning the position of the crank on one side is shifted 90 degrees from the other side. Why do they do this? To avoid the situation I'm dealing with right now. Steam engineers quarter the wheels so that the valve piston is always admitting steam on one side. One side might be closed off, but the other side is shifted 90 degrees forward or back so that the valve is admitting steam to the piston and the train can move forward or reverse. Fortunately, I knew this fact going into this design because I designed square openings in the drive wheel axles to accommodate some 4x4x12 millimeter steel machine keys. Therefore, my problem would be solved by building the other half of the locomotive. Now, my responsibility to you, the viewer, is to not bore you to death, so we're going to speed run this part. Here are all the additional parts I had to print, including the mirrored components we discussed earlier. Here, I'm inserting the machine keys into the drive wheel axles to quarter them, and then attaching the other half of the partially assembled chassis together. I redesigned and printed the piping network, so I'm having to rethread the NPT coupler into this new resin printed part, and then mount the entire piping network onto the cylinders. By the way, you might have noticed the assembly sitting on that stand I designed. This was printed off camera. Everything was in place and rolling nicely, although there was some friction present, so I bought a can of silicone lubricant and sprayed it inside the cylinder bores, on the piston shafts, and inside the crosshead guide. I then buttoned everything up by screwing the cylinder head plates onto both cylinders. How's that for summarizing 4 days worth of work? Back to testing, this time using a much lighter gauge hose. I began pumping in air and it works. I was thrilled because even though your model might be square to the world in CAD, the physical world just introduces so many potential errors, so almost anything could foil the function. After a successful full throttle forward test, I ran this screw to bring the radius rod further up in the expansion link to simulate the locomotive in reverse. With a burst of air, the model fired into reverse, confirming my Walschaerts valve gear is properly set up.